Salam and hi, we are Group 7 and we're presenting on research misconduct and ethical engineering. In this presentation, we'll explore the fine line between honest mistake and unethical practice in research, why integrity matters in engineering, and how can we uphold ethical standards. So I quickly distinguish between research misconduct and honest mistake or errors in research. So research misconduct refer to intentional acts that violation of ethical standards. It include fabrication, for example, making up data that doesn't exist, falsification, manipulating research processes or data, like tweaking results to fit a hypothesis, plagiarism, using someone else's work without proper credits. So these are always deliberate and unethical behaviors. On the other hand, mistakes and errors are unintentional. This could include incorrect calculation, data entry issue, instrument setup errors. For instance, misreading the load capacity of a material is an error. However, overstating it deliberately for personal or professional gain is misconduct. Errors are honest and can be correct when identified. So, in short, misconduct is deliberate and unethical, while mistakes and errors are unintentional and correctable. Understanding the difference is the key to maintain integrity in research.
Okay, thank you. Okay, my name is Muhammad Taufik. Metric number TM21014. Today, I will present about recent attention to research misconduct. First is high profile scandal, which is a prominent case of research misconduct such as data fabrication, falsification, or plagiarism have drawn global attention. For example, the retraction watch database and COVID-19 research scandal. Second is consequence of misconduct, which is for science, misconduct erode trust in the scientific process and the credibility of published research. Next is technological advance reveal misconduct, which is tools like plagiarism detector, for example, Tunitin and data analysis software. For example, image forensic have made it easier to uncover the unethical practice in published research. Next is growing awareness of ethical practice, which is institution or and journals are now placing more emphasis on ethic through mandatory training, strict peer review process, and reproducibility checks. Next is financial and social costs, which is research misconduct waste resource, including public and private funding. And lastly is global impact, which is misconduct doesn't just affect the individual or institution involved. It has for reaching consequence on global research, collaboration, policies, and engineering practice. That's all from me. Thank you. Next, I will pass to Kishan.
Good morning, everyone. My name is Kishan Murugan. My matrix ID is TM21012. So, we are from Group 7 and our topic is Research Misconduct and Ethical Engineering. And there are actually two differences. First, falsification data selection. The second one is legitimate data selection. In falsification data selection involves manipulating, altering, or fabricating data to mispresent research findings. Researchers may modify results to fit a hypothesis or hide unfavorable data. Considered research misconduct violating ethical and professional integrity. For an example, changing numerical values in an experiment to produce expected results. The second one is legitimate data selection. involve choosing relevant and valid data based on justified scientific reasoning. Researchers follow ethical guidelines to exclude unreliable or irrelevant data, such as measurement errors, outliers, with justified reasoning, and also do not alter or misrepresent findings but ensures accuracy and reliability. For example, removing a sensor reading due to a clearly identified malfunction with proper documentation. Thank you.
Hello, hello and good evening. And I'm Yoganathan, son of Raghunathan here. And today I'm going to present uh, today I'm going to present the case study on example case study on research misconduct in engineering. Lessons from the Mark Hauser case. Okay, first case overview. Mark Hauser, background prominent researcher in cognitive neuroscience. Fields impacted AI, robotics, and biomimicry inspired by cognitive models. Nature of misconduct, fabricated, falsified experimental data, lack of transparency in methods and reporting. What went wrong in this research misconduct in engineering? Altered data to fit hypotheses, inconsistent or absent documentation, ethical breaches affecting foundational insights for engineering systems. Broader consequences of misconduct. What happened? Restriction of multiple studies, negative ripple effects such as delays and extra costs in engineering projects, misleading cognitive models affecting AI and robotics, erosion of trust in interdisciplinary research. Broader lessons for engineering, we can learn that importance of peer review, thorough validation of interdisciplinary research, data integrity, transparent documentation, accessibility for replication, caution in application, verifying the credibility of findings from the other fields, preventing misconduct in engineering. What can we prevent? Promote a culture of research ethics, implement strict guidelines for data collection and reporting, increase collaboration and independent replication efforts. Closing thoughts, ethical research in the backbone of innovation. Misconduct undermines trust of and leads to real-world consequences. Engineers must uphold rigorous standards, especially in interdisciplinary fields. Interdisciplinary fields. Okay, next conclusion. Okay, conclusion. Research misconduct such as fabrication, falsification, and plagiarism undermines the credibility of engineering and science. It has far-reaching consequences from delayed innovation and increased cost to public safety risk and erosion of trust in interdisciplinary research. Ethical engineering demands a commitment to integrity, transparency, and accountability. By adhering to rigorous standards in data collection, reporting, and peer review, engineers can ensure that their work is reliable and impactful. Next, promoting a culture of ethics and fostering open collaboration across disciplines are essential for building a foundation of trust and advancing technology responsibly. In a nutshell, ultimately, ethical engineering is not just about preventing misconduct, but about prioritizing solutions that benefit society and protect public interest. That's all from us. Thank you. Honest mistakes can be corrected, but dishonesty damages trust forever.